Sanjaya Kamat and welcome to my channel. In this video today I am going to teach you how to prepare BBS bar bending schedule of any materials. Okay, so of any parts of the buildings. So in this video one by one I will teach you also, and one by one I will explain you also how this value will come, how this topic by topic I will teach you also, and I will explain you also. So listen to me carefully so that you can understand. Okay, so okay, one by one topic it will be. Okay, so as all you know, see, staircase steel quantity. So how much steel quantity is required and how we are going to prepare the steel staircase. Okay, during that time how much material is required, concrete material is required, and how much quantity is required, how much rod we have to bend. Okay, so these all things now we will study. Okay, so if we see, suppose we can't keep horizontally, so the can't keep vertical. So everything we have a rule, no, so process rule, no, according to the process, according to the rule that we will do. Okay, so let's say we have to prepare BBS of 11 stairs or 12 set stair. Okay, 15 riser, and it depends upon the height of the buildings, or height of the buildings and stairs of the buildings, staircase of the buildings, and sloping of the staircase. So depending upon that, we keep the steps of the staircase, or steps can also be known as the riser, and then treads, no, treads and riser. So in staircase we have two things. One is riser, another is tread, and uh, beginning of the staircase is the landing one, and no, and ending of the staircase is the landing two. So one by one now I am going to explain you. As you can see in figure here, so better you follow to my cursor of mouse of the cursor so that you can easily understand. Okay, so see here, this is a staircase. Okay, a staircase, landing one and landing two, as you can see in this figure. Are you capable to see? You can see here, landing one. So this is the starting of the staircase. Okay, from we move from step 1 to step 2, step 2 to step 3, step 3 to step 4. Similarly we step 4 to 5, 5 to 6, 6 to 7, and similarly we reach up to land 2, and from land 2 we move to the left hand side. And after moving to the left hand side, you will again start to move to the upward position. So this is the our step rise and trade here. Step 1, step 2, step 3, step 4, step 5, step 6, step 7, step 8, step 9, step 10. So similarly we reach up to the landing 1 to landing 2, to the higher position, higher level, and higher level is here. Okay, so see, this total dimension is how much? 1000 mm, this much, from landing 1 to beginning of the landing 1 to ending of the landing 1. And this bottom middle of this part of the staircase is 2500 mm. Okay, 2500 mm. And this much is your landing 2, and landing 2 is how much? 1000 mm. Okay, and this much, this, the breadth of the staircase is how much? 2500. Okay, so breadth of the staircase is how much? 2500. Similarly, so this is your plan. Okay, plan of the staircase. This, see, where we take turn, when we turn, that position is how much? And this turning position of the staircase is how much? This is 1200 mm. Okay, and the gap between the staircase landing 1 and landing 2 is how much? 100 mm only. So this much 100 mm gap we have to leave, and after leaving this 100 mm gap we have to make the staircase. Okay, this is the method, this is the process. Okay, so this is the plan. So as we all know the given data from the figure, so now we can calculate for the staircase. Okay, So further, one by one I am doing also, and I am explaining also. See, as you can see here, see, this is the landing. Okay, so here landing we have to keep the rod here between the bar. You see, bar 1, bar 2, bar 3, bar 4, bar 5, bar 6. We have to, and we have to bend here. Okay, here if you bend here, this is 45 degree. We have to bend here. We have to keep rod here horizontal, and again you have to keep this up to 200 vertical. Okay, and then ending of the landing one here, this point is the landing, ending of the landing one. Okay, so from here to here, see, are you looking to my cursor? Okay, from here to here is your what? This is the, this is your uh, this is, what is this? This is your landing one, and ending of this landing one, and from here to here is the sloping. We bend this rod up in upward direction. In upward direction, uh, in how many degree? Okay, in how many degree? In 45 degree only. We have to bend this rod in 45 degree only. Okay, from here to here. Okay, now we know this value. After bending we know this, no? And from here, see, this is the starting starting 45 degree, and this is the ending 45 degree sloping. Okay, so, and this is the landing. Okay, and this is the landing, and then this is the ending of the sloping. So from ending of the sloping, we again bend this rod to the horizontal position, in horizontal position. We bend this rod in horizontal position, and we bend this rod in such a way that this will be what? Landing 2. Okay, so see, we have a formula: riser is equal to trade plus 1. Okay, so in every riser and trade, in every steps, we observe, we have a triangle. In this step also we have a triangle, in this step also we have a triangle. Every step, every riser and trade, we have a what? A triangle. So in between that, what we will do? We will do here, since we have a right angle triangle in a staircase, we observe that we have absolutely a right angle triangle. Then we can use the hypotenuse theorem. Hypotenuse theorem is how much? H square is equal to p square plus b square. So same thing we use here also. Okay, so we can see this, this vertical is your riser, and horizontal is your trade. Okay, and this landing, early I show you this landing is your, landing one is the how much? 1000 this is the landing one. Okay, and then width of this is, no, breadth of this, height of the landing one is 250 no, as you can see here. And then similarly, the thickness of this staircase is how much? 125 in between this, we have to fill the concrete materials, no? And then see, we know this, and then see, we keep this rod, no, of size of how much dimension of thickness, 10 tension, this is the thickness of the bar, 10 rod. At how much clear cover we have to keep the, we have to keep the space between that. Okay, so in between 200 gap we have to keep the clear cover. Okay, and this is the extra bar, so this is no more, this extra bar. Okay, so, and see, this is the landing 2, and slab thickness is 200 and similarly here you can see this thickness is 400 from here to here. Okay, the height from bottom, from top to bottom is 400 and this again, this breadth is how much? 250 okay, as you can see, and landing 2 is also 1000 here you can see. Okay, so and see, the space between the riser and trade and this rod, sloping bar, this gap is called what? Waist slab thickness. Okay, waist slab thickness, and this is of how much? 125 as you can see here, no? 125 and see, the gap between the upper bar and the lower bar, between the reinforcement is what? Landing slab, and this thickness is how much? This thickness is 200 mm only. Okay, as you can see in this figure. Okay, so as we know this, and see this part is called L by 7. Okay, this part L by 7, and L is longitudinal by 7. Okay, so this is the section, and here you can see this is the beam. Okay, starting of the beam from where we start the landing one. Okay, this as you can see, and alternate, see here also bent up. See, cover for stair is how much? 25 mm, and the cover for beam is how much? 30 mm. So, and the length of this, see, from landing 1 to landing 2, from here to here, since this is sloping, and starting is landing 1 and ending is landing 2, but the length between the landing 1 and the landing 2 is how much? 4500 mm. Okay, as you can see, then we know we can convert this mm into meter. So 4500 mm is equal to how much? 4.5 mm. No, 4.500, 4.5 meter. Okay, so now we are going to work for the shape of the bar. See, as you can see, then this was the section, and this was the plan. This is the plan. Okay, and this is the section. Now if we see in general, after bending, the figure can be, the shape of the figure can be look like this. Okay, vertical, again horizontal, again sloping, again horizontal, and then again sloping, then again horizontal, then again bend that rod to the downward position, and that will be vertical. Okay, so as you can see, let this portion be A, let this portion be B, let this portion be C, and let this portion be D, as you can see as shown in the figure. Okay, and if we talk to the shape 2, how is possible this? We neglect this part. Now we neglect this part. Okay, and if we left this part, if we left this beam, then how, what happened? See, E to this is G, F to G. Okay, so E is horizontal, F is sloping, and G is again horizontal, and this rod is again bending to the downward position. Okay, so in shape theory, as you can see, again this bed is sloping, and again this rod is, again this bar is what? Horizontal, sloping and horizontal. So we can take this part is as H, and this part as L. Okay, and this sloping is 450 mm. Okay, as you can see, now we now we are going to calculate for the number of the bar. Okay, to calculate the number of the bar, see, suppose in a staircase we need a different number of the bars. So how much bar we need for this dimension? So that we are going to calculate. To calculate the number of the bar, see, number of the bar is equal to width of the flight minus clear cover by spacing plus 1. This is our formula to calculate the number of the bar. And this number of the bar I have shown 2-3 years before. Okay, to calculate how to number of the bar, as you can see my previous video to how to calculate this. Okay, I have taught there. So now see, width of the flight is how much? 1200. As you can see, width of the flight is how much? 1200. How much? 1200. Here see, 1200. Yes or no? 1200. Now width of the flight is 1200 no mm minus clear cover is how much? Two side cover 25 mm by 100. Spacing is how much? Spacing is how much? 100 mm. See, you can see this in between this landing and this landing is how much? 100 mm. As you can see here, look at mouse cursor. Okay, so 100 mm. So we keep this 100 here and plus 1. After doing this, how much side? Two side is there. Side cover is how much? 2. Then cover is how much? 25 mm. If we multiply this 2 into 25, this will be 50. Okay, once we know this, then do this in calculator. You can easily, it will come 12.5. Let's say around approximately this is 13 numbers of the bar we can assume. Okay, here. So we know how much bar is required here. 13 bar, 13 number of the bar. Now crank bar is how much? Number 7. And normal bar is how much? 6 number. Okay, normal bar is 6, and crank bar means you have to bend. If you bend that bar, that will be converted into crank bar. Okay, so how much bar we have? 7. Crank bar is 7, and normal bar we are taking here 6 number. Okay, so now we are going to calculate for the calculation calculation of bar shape number. Okay, calculation of bar shape number. So this is your, let's say, early before bending. No, before bending our rod is straight. Okay, so after bending our bar is looking like this. Okay, so one bar is sloping, another bar is horizontal. So this is clear cover is how much? 25 mm, and this thickness is how much? 200 mm, and this is L by 2. Okay, and this is your cover. Okay, see this cover. Okay, this cover from here to here, and from here to from here to here, and here to here. So this gap, this dimension, this gap is how much? To calculate this d dimension, 200 minus, if we minus from, if we minus 25 from 200, then how much it will come? It will come 150 mm. Okay, so we have calculated this d dimension and this gap. Okay, now we are going to calculate the a. Okay, so as you can see, what we assume here, we assume this as a. Okay, so now this part we are going to calculate this part. Okay, from this figure. So to calculate this, see, you can see a is equal to L by 7 plus 0.42 d, where d is the depth of the slab, and just now we calculated the depth of the slab. Okay, so this covered part, we have assumed this covered part as a. Okay, so we are going to calculate this a. So as you can see, after substituting these all value, see our L is how much here? L we have how much? Early I told you 4500 L. See this. Okay, so if we, how much? 1000 plus 1000, how much it will be? 2000, and 2000 plus 2500, how much it will be? It will be 4500. So 4500 mm total we have. How much we have? Longitudinal bar. Okay, so L by 7 plus 0.42 d, and d we have just now we have calculated depth. Okay, so depth is how much? 150 mm. So we keep this 150 in this formula. Okay, so we can easily calculate the value of a portion. Okay, a part. Okay, so after calculating this, if we do divide 4500 by 7 plus 0.42 into 150, then how much it will come? It will come 706 mm. Okay, now we can use calculator. Once I will show you in calculator how to use. Okay, let's see, my net is somehow slow, that's why. Okay, not working properly. See, now we are going to calculate this. Okay, this formula. Okay, how this a is equal to 706 mm km. Okay, to understand that, to understand this, we have to type how 4500 divided by 7. If we do, how much it is coming? This much, plus 0.42, and multiply again how much? 150. If you do, then how much is it is coming? Okay, 706. Oh, sorry. Do this way, 0.42 multiply, do 150. How much it will come? 63. Okay, 60. Then do what you do, 4500 divided by 7. If you do, how much it is coming? See, this much. And we know or plus how much we have to do the addition. Orally we have to multiply. Okay, so now we have to do addition. I haven't seen this. Okay, addition sign. So now after doing this multiplication, how much it is coming? It is coming 63. So do how much it is coming? So 100 705.85. So this see after decimal we have 85. Okay, so we can round up this. After rounding we can assume this as no 706. We can take approximately 706 mm. Okay, so we know 706 in this way. How this 706 came, we understood. Okay, so now see, in everywhere you can see riser trade, riser trade, riser trade, riser trade. In every step we can one triangle will form. Okay, in every triangle. So we have taken only in between that riser and trade, we have taken only two triangle. As you can see, triangle 1, triangle 2, triangle ABC. Another triangle we have taken DEF. See, so what happened is, now see, let assume AB is equal to C prime, and then AC is equal to 1800 mm, and BC is equal to base. And here similarly, D is equal to 292 mm, and DF is equal to 150 mm, and EF is equal to 250 mm. So once we know this value, by proportion theorem we can calculate for what? C. Okay, this C, AB, we can calculate for AB. So by proportion what happened? See, A by DE. See, in compare this triangle ABC to triangle DEF. AB by AB by DE, can we write AB by DE? This side is equal to this side, uh, and is equal to AC by DF. Can't we write? After writing this, so now we have a formula, we have a value. Then I have the written for this, no, CI as a C dash. Okay, so you can, but to understand, in place of CI you can write AB also. No, this is up to you. Okay, so CI by 192. DF is how much? D is 192. To write down this 192, and then 1800 is what? AC. AC is how much? AC is 1800. 1800 mm. Now DF is how much? DF DF is 150. Okay, so we have now only one unknown. Only unknown. So only one is unknown. So we can calculate for one CI. So you can calculate for this. Okay, so once we know this, the you can do for calculator. See, how much? 18. I will see this, show you in this calculator. See, to do this, to bring this, how much we have to do? 1800 divided by 150. This is coming to 12. And if we multiply this by 292, then how much it will come? 300, 500, 3504 mm. Okay, so in this way, this scheme. Okay, so cross multiply, then you can easily get this value. Okay, so after getting this value, come to the next. Okay, moving to next figure. So this is also a staircase figure, but this is the separate figure. So A we have handout, clear cover we have given the 25 mm, base we have calculated here. Okay, so base we can know. See here also, in between downward also we want a rectangle can form. Okay, so triangle can form here. Okay, so and in upward position one rectangle can form. So what is possible here? So to calculate here, so you have to keep this mind that this is the clear cover 25 mm, and this is you, between this is how much? This is another triangle from BAC. Okay, BAC. So here this is 90 degree, and here this is base BC. BC is your base. Okay. So each step, each trade is how much? Each trade is 150 and riser is how much? Riser is 250. Okay. So riser is 150 and trade is how much? Trade is 250 Okay. So once you get this, then how much? I mean, always trade be greater than riser. Okay. So note that. Note. See, slab depth is how much? From this figure, we have some value is here given here. We can observe some value from this figure. So slab depth is how much? 200 and number of the riser is total how much? 1 2 3 4 5 6 7 8, total 9. Just below there is also one, no? So you can see there in top of the figure, 1 2 3 4 5 6 7 8 9 10 11. So total 11, as you can see here. So total number of the riser is 11, and riser riser height is how much? 150 Okay. So we know two side is how much? Two side is 2 2 into 150, 25. If you do, then how much it will come? 50 Okay. Two side cover is, so we have to multiply with the two side cover. Okay. So side cover, if you multiply 25 into 2, then this will be 50 So now you can see this is the 1000 Okay. From here to here, this is your landing 2. Okay. So because we are moving to the upward position, upward side. Okay. This is the upward position. Now here is also riser is how much? 150 Once we get the 150 riser, then we can calculate it for the waist slab thickness. Then waist slab thickness is given how much? 125 Now clear cover is how much? 25 Once we get this, how much this? This is the dimension. This is the dia of this middle part. Okay. So from here to here, from point H to this part, landing two position. Okay. So now we are going to calculate it for the BC. Okay. Where is BC? BC, as you can see, this BC base. Okay. Because this is unknown. So to calculate again, we will do by proportion method. Okay. So by proportion method is BC by EF. BC by BC by EF. BC by EF. BC by EF is equal to AC by DF. Okay. So if we substitute this, then earlier we got the value of no CI. So CI is that is nothing but that is the AB. Okay. AB side. No, this value, this value we have got, no. As you can see, this CI. C prime is AB. AB we have got this value. Once we know got this value, then keep that value in this formula. If you keep that formula, then solve for BCI, then you can get BC. Okay. Then divide, first of all divide 1800 by 150. After dividing, multiply this with this, then you will get the how much? 300 Then 300 is equal to how much? 3 meter. Okay. Similarly, after solving that, you can come here. Okay. So this is the triangle. Another triangle we have assumed here. This is the JKI, and another formula figure we have taken the DEF. Okay. So as you can see here, now what is possible here? So this is also triangle. This is also triangle. See, this side is equals to this side. This is hypotenuse. This is base, and this side is perpendicular. And in this figure, in this triangle DEF, this side EFD side is perpendicular, and EF side is base, and DE side is your hypotenuse. This can be decided on the basis of what? On the basis of right angle triangle. In this figure, this is the right angle triangle, and this is the this side, this is the right angle triangle, and this will go, this is the hypotenuse, just opposite of the right angle triangle, opposite of the 90 degree. This will be hypotenuse. So now using the Pythagoras theorem, you can calculate it for gi. We can calculate for, you can calculate it for gi and ji. Okay, so ji is how much? Now after solving, you can solve this, you can do cross multiply. Do cross multiply. After doing the cross multiply, you can get the ji is equal to 116.85. Okay, so you can see here, you can get this from this figure. Okay, again, once you get this ji is equal to 116.85 mm, then what you can do? You can do, gi is equal to gj plus ji. Now substitute this ji value here in this formula. Okay, so once you substitute this formula in this here, then what is possible? What you can do now? Keep this. How much? Gj is how much? Gj is 150 mm. From this figure, you have this here. Gj. Gj is how much? Gj is how much? 150. Okay, 150 mm. And then Gi. Gi is how much? We have brought here in this. After solving this, we have brought this 116.85 mm. Okay, so Gi is 116.85 mm. So after solving this, see, once we get Gj plus Ji, then can't we do the addition? See, in between this Gj plus Gj and Gj and Ji, we have a what? Addition sign. So now what you can do? You can do the addition. Okay, you can do the addition. Do addition. After doing the addition, what you can do? uh, gj gj can be taken from here. Okay, okay, so gj is equals to 150 minus 25 and plus ji is how much? Ji is 116.85 mm. Okay, so now what is, we have all value, gj also and ji also. Then do the addition and do the subtraction here. First of all, you do the addition. 150 plus 116.85. Now you can do calculator here. Okay, as you can see, we can use calculator here. See, what you can do. 150, do one thing. 150 and plus 116.85. Do the addition first, then what you will get? 266.85 minus, now you subtract 25 from 266. Okay, now what you will get? How much you will get? 241.85 mm. Okay, so in this way you can subtract and do the addition. Okay, so coming to this figure. Okay, in this figure you can, what you can do now? You can do, see, same figure, but we have taken the, we have round, no, turned in anti-clockwise. Okay, so this is g h I. Now this is e f d, the e f. See, riser we have already 150 mm. And to find the gj, gj, to find the gj. Okay, gj, reduce cover, reduce clear cover 25 mm from the waste slab. Okay, waste slab, earlier I told you, earlier waste slab is, I have shown you. Okay, waste slab is this. Okay, this is the gap between this. Okay, so waste slab thickness is this. Okay, as you can see in this figure. Okay, so waste slab, now we are working for the what? We are working for the gj. Okay, to calculate the gj, what to do? What is, so so in this figure, in triangle gih and triangle def, so gh by fe, we can write is equal to gi by fd. Okay, gi by gh by fe is equal to gi by fd. Okay, so you can do. So now in this figure we have gi. Okay, gi, how much we have? gi is, 240.85. Okay, and fd is how much? Fd is 150. Okay, so we just write down just below. Okay, we write down just below. Okay, at a numerator. Okay, denominator, and then GH is how much? GH we don't know. We have to calculate for it. Okay. And now we know the Fe value. Fe is how much? Fe is 250 mm. So we keep this all value in this formula. So once we know this all formula values, then we can calculate for what? We can calculate for GH. Okay. So calculate for GH. Then how much it will come? It will come after solving earlier how to solve. I told you. Okay. So do the division first. 241.85 by 150. How much it will? I will show you in calculator. Okay. First of all, do clear. Okay. 241.85. Okay. Divide by 150. If you do, then how much it will come? 1.61. Okay. Now do multiplication with the how much? 250. How much it will come? 403.08. Okay. So in this way you can calculate for GH. Okay. Now see what we have to calculate. We have to calculate for D. Okay. We have to calculate for D here. Okay. To calculate D, we have to subtract. See why which we are going to calculate. See this D is, I will show you from figure. This part we have assumed as D. So earlier in the second page I have shown you. See this part we have assumed as D. Okay. See, as you can see this part we have to calculate now. See this. Okay. This here. You can see to my cursor. Okay. This part we have to calculate. So to calculate this, do so GI we have calculated. Calculate D. Now to calculate D, what we have to do now? We have to subtract 403.08 from what? From 1000. If we subtract 403.08 from 1000, then how much it will come? It will come 596.9. Okay, 596 point how much? Subtract, do calculation, use calculator. Subtract 1000 minus how much? Subtract 1000 minus 403.08. How much it is coming? 596.92. But see, after decimal how much it is coming here? 92. So you can round up this. If you round up this, then this will be 96 will become the 97. Okay. So this approximately you can write 597 mm. Okay. So now we know the value of D. So after knowing this value of D, we can calculate for B, breadth of this staircase. Okay. So in figure of which part we have assumed B, so we are working for the B. Okay. So now we are going to calculate for B. So B is equal to L minus L by 7 minus BCI minus D. This is the formula to calculate the breadth of the staircase. Okay. So 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 L is how much? 4500. We have to write the length from the landing 1 to landing 2 is how much? L is landing length from the landing 1 to landing 2 is 4500 mm, and minus L by 7 is how much? 642.857, and minus BCI is, we have calculated here is 3000. Okay, as you can see here 3000. BCI is how much? 3000 base is 3000. So we keep the BCI as 3000, and then minus D just now we have calculated is 597. So once we know the all value, then you can easily calculate it for it. Okay. So you use the calculator to calculate this. Okay. So just now erase this all first of all. Do one thing. So type 4500 first minus then 6, type 42 642.857 minus again minus 3000 and minus 597. If you do, then how much it is coming? 260.143. It's coming or not? So 1.3 is coming. So neglect this decimal because this is no more required. See, if you round up, then this will be approximately this much only. So we have taken the 260 mm only. Okay. So you can see 260.143. See, you can round up after 5 only. So this we neglect this. This is we have to take the how much? 260 mm only. So this will be 260 mm. So once we get the value of breadth of the thickness of the staircase, now we work for the development length. Okay, to calculate the development length of the staircase, see we have to add this 220 mm, 220 mm. This the length between the these two bar length. Okay, 220 mm plus 170, and the breadth of this vertical height of this bar between the first rod to second rod. Okay, and this is 170 mm. Okay, so after doing the addition, how much it will come? It will come 300. Development length will come 390 mm. Okay, so now we will calculate for the cutting length. To calculate the cutting length, we have to do the what? We have to do the addition from the part A to part D. Okay, portion of A to portion of B. Okay, portion is part of the staircase. Okay, A part we have taken the we have calculated, B part also we have calculated, C part also calculated, D part also we have calculated. Now we have to add the development length. Okay, development length minus bend. How much we have bended, that part we have to take here. Okay, so after taking this, see, once all value now we have, so substitute those all value here. And how much here? A is 706 mm, and B is how much? 260 mm, and C is how much? C is 3504 mm, and D is how much? 597 mm, and plus D length, development length is how much? 390. Okay, and bend is how much? Bend is 2D, and which is 2 into 2 into 10. Okay, so after solving this, to solve this, after solving you can get 5767, which is approximately, if we convert this mm into meter, then how much it will be? It will be 5.767. Okay, as you can do, to convert this, what you have to do? Clear first. 5767 divide by how much? Divide by, oh sorry, 57 5767 divided by how much? Divided by 1000. If you do, then how much it is coming? 5 point is equal to 5.767. Okay, this much it is coming. So here, so you can see here, after decimal, 5 point after decimal we have a 767. Okay, 767. So this time you can do the round up. If you do the round up, then this will be the 6. Okay, so we can't take the decimal rod, no. So this is, we have to round up this. Either you can decrease, either you can, if there is the possible to increase, you can increase. If not possible, then you can leave it as it is. Okay, so this will be how much? Number of the bars is required here, 7. Okay, so we calculated number of the bars. Now comes to the total length of the bar. Total length, to calculate the total length of the bar, what we will do? We will do multiplication with the 5.767 into 7, because the number of the bar is this much and the total length is how much? 5 point, cutting length is 5.767. So multiplying, after multiplying you will get the this much, 40 point. Let us do the in calculator. Okay, so clear this first. 5 point, how much it is coming? Total length of the bar 5.767 multiply by 7, how much it is coming? 40, 40.369. So approximately this is 40.4. Okay, 40.4 meter it is coming or not coming? So now explanation of what? Crank bar. Now crank bar means this all bended bar. Okay, bended bar, how much, where we have bended, that part we are going to calculate. Okay, so now calculation of the bar shape of the bar shape number, bar shape number 2. Okay, so you can see here this circle part is the what? Bended bar. Okay, so to calculate this, and this is also 2D bended here, horizontal and vertical, here also we have bended here. Okay, so to calculate this, this is the eccentricity. L by 7 plus b, L by 7 plus if we do, then we will, earlier we have b value, we can keep this b value here to 60, to 60 here, okay, by L by 7 plus 45, 4500 by 7 plus 260 if you do, then this much it will come 903. We can do in calculator first, okay. L by 7 4500 divided by 7 if you do, then how much it is coming? 640, 642, and plus b is how much we have 6260, okay. So how much it is coming? 902. And this after decimal how much we have? After decimal we have 85, 85. So after decimal it is 8, you can do round up here. So after doing round up, how much it is coming? 903, okay. So 903 mm. So once we get the E value, now we calculate for the C, and C is the flange width, okay. C value is the flange width, which is equal to C also, okay, which is equals to C also. And if condition is here, condition is given, then we can directly do the equal, okay, with the C value. So F is equals to C from this above condition, okay. So F is equals to C from the above condition, then you can easily, what we can do, we can do the F is equals to, we can write F is equals to 3504 mm, okay. So in this way you can do the calculation, okay. So similarly, if to calculate a G value, what we have to do now? To calculate G value, G is equals to D. From figure, from above figure, G is equals to D. So this time we cannot calculate, okay. We don't have to calculate for G value. We can easily, you can easily write the G is equals to D value, okay. So G is equals to how much? D value is equals to G value. So G is equals to 597 mm, okay, from the above condition, okay. So now look at this figure. Look at this figure. This is the bended part, and this is the vertical part, and this is the vertical part, okay. And this is the horizontal part, and this is also the horizontal part. And this is the what? This is the width of the beam, and this is the length of the beam. So width is how much? This up to here, and here to here is bended bar, bended rod. So from here we have to subtract 250 minus 30. How much it will come? From here to here, 220, 220 mm, okay. And similarly, this part to this part, this part to this part is how much? 200, 200 minus 30. How much it is come? From here to here is 170 mm only. And from this part to below part, how much it is? It will come, which is equals to development length, to 20 mm plus 170 mm is equals to how much? 390 mm, okay. So in this way you can calculate. Now we are going to calculate for the cutting length, okay. Cutting length for this figure, okay. To calculate for the cutting length for the above figure, we have to do the addition of C plus F plus G plus development length minus D, and substitute this all value in this, because now we have C value also, F value also, and G value also, and development length value also. Earlier development length value is here, and development length value is here, okay. Development length value 390. So substitute this value here, okay, and substitute G value and bend value, and after solving you will get the number of the bar, how much? Cutting length bar is how much? 6, okay. Total number of the bar will be 6. Then total length will be how much? Total length will be now, total length will be 5. Use calculator for this, and now I am using calculator, okay. To use this calculator, see how much we have to calculate now. 5.5.547, 5.547, sorry, 5.547 5.547, no, 5.7 multiply is how much? Multiply by 6. How much it will come? How much? Multiply this. 33.44 is coming or not? So 33.44 meter is coming. Okay. So this much is your total length in the, for above figure. Okay. Now we are going to calculate for the bar shape number 3. Okay. Bar shape number 3 from for this figure. Okay. So as you can see, we still have this much. Waist slab is this much. Okay, and this is the width of the landing tube. This is 200 mm. Now if we extend this part, this line, if you extend this line, if we extend this line, and if you extend this line, and if we bend this line, if we join with this line, this line, this 200 mm line, then this type of figure will form in this figure. Okay, okay. So here you can see two triangle will form. Okay, so two triangle will form. Then what you will do? You can do this will be r will be 150 mm, and this mn will be the hypotenuse, and this mu will be 75 mm, and this will be the perpendicular, and this will be hypotenuse. So now waist slab length will be minus 2 cover. Waist slab, what waist slab will be 125 mm minus 25 minus 25. How much it will come? How much it will come? Hypotenuse now 75 mm. Okay, and beam is how much? Beam is 200 mm. So minus what we have to do? Two side cover will be how much? It will come. It will come 150 mm. This speaking. It is already given here also. Okay. So this will be, this angle will be equal to this angle. This will be being vertically opposite angle. Okay. And this angle is equals to this angle, alternate angle. Okay. And this angle m is equals to angle r. This will be also alternate angle. Okay. So this, as you can see, this is the sloping 450 mm. This is the inch, which is height. Okay, sloping of the height. No, and this is, we have assumed this portion as inch. Okay, and this we have assumed as a portion as I. Okay, so in between this also this type of triangle will form. Okay, and this type of figure will form. Then uh, in figure, DE will be 250 mm, and DF will be how much? 150 mm, and EF will be how much? 292 mm, and which is hypotenuse. See, now you can assume, now you can see this is the right angle triangle, and this will be 90 degree, and the opposite of this side will be the hypotenuse, and this will be the base, and this will be the perpendicular. Okay, so in triangle, MNO and ADEF, what is possible? We can calculate again. You can do the same thing. MN by FE is equal to MO by DE, or MN by 292 is equals to all value we have. So all nothing I am doing. I am just substituting all value in this formula. Okay. So MN by 292 is equal to how much? 76 by 250, or MN is equal to how much? After calculation, how much it will come? 87.6 mm. Okay, in this way you can calculate for mn value. Mn is equal to how much? 87.6 mm. Again in triangle MNP and triangle DEF, MP by DE is equal to MN by DF, or MP by 250 is equals to 87.6 by 150, or MP is equals to how much? If you solve this, substitute those all value, nothing, all value we have now. So how much it will come? MB is equals to 146 mm. Okay, similarly again in triangle PQR and triangle DEF, PR by DE is equals to QR by DF, or PR by 250 is equals to 150 by 150 by 150, or PR is equals to 250 mm. Okay, so in this way you can calculate extra bar is equals to h plus I. No, in this way how much extra bar will come? 1443. Okay, 1443 mm. Okay, so in this way now cutting length is equal to extra bar plus development length minus bend. This is the formula, early formula. So substitute this all value here. Extra bar is now just now we got, okay, 1443 mm. Okay, and development length early we have. Okay, so this is the extra bar. Okay, so you can write right here extra bar. Okay, extra, you can write this extra bar. Okay, so this is the extra bar. Okay, so you can this, you can write this is the extra bar. We are writing this is the extra bar topic. Okay, is equal to after here you can write equals to sign also. Okay, because we are working for the extra bar. Okay, so how much we got this much bar. Okay, equals to here also. Write down is equals to here also. Sorry, next page on this much. This much it will come, and then you can do how much we got 1443 mm. So substitute this. Now we have extra bar also. Extra bar is how much 1443, and development length we have calculated earlier, and now then bend also we have calculated earlier. Then substitute this all value in this formula. Now you can easily get the, you can easily calculate for the what cutting length, and cutting length is how much 1.653 meter. Okay, you can see. now now we are going to solve for this figure. Okay, this beam. Okay, and see width, breadth of this beam is how much 250 mm. Okay, and then length of this thickness, length of this bar is how much 250 minus, because we are reducing this space. Okay, and this space is how much 30 mm. We are taking this part only from here to here. Okay, this much only up to red line only. Okay, so 250 minus 30 will be how much 220 mm. Okay, so now we are going to calculate for the number of the bar. To calculate the number of the bar, what we have to do, we have to do the uh, we have a formula width of flight minus clear cover by spacing plus 1. So keep this all value. Width of the flight is 1200 mm and clear cover is 50 and plus 1. If you do, then how much it is coming? It is coming 6.75. Okay, but number of the bar, we don't have any unit for the number of the bar, so it is unitless. Okay, so write on the number only. Okay, so it is coming how much 6.75, and this is approximately equals to 7. Okay, so for number of the bar length is equals to how much 1.653 into 7, how much it will come now? This is the 11.571. This time also you can do the round up, because this is the greater than 4. 5 is the 5 is the greater than is 4. Okay, so we can round up, but leave this time. Okay, so this is 11.57. So now we are going to calculate for the binder. Okay, so how much length we have binded, how much bar of the, how much bar we have binded for the staircase. Okay, so that we are going to calculate. So cutting length is equals to how much width of the flight minus 2 cover. See, from 1 hour approximately, if it becomes the 1 hour, I am going to talking. Okay, explaining one by one topic by topic. So my throat is somehow I am feeling, my throat is feeling difficult to speak. See, since we have now width of the flight minus 2 cover, then what do you do? Subtract this, subtract this 50 minus 50 from the 1200. So how much it will come? 1150 mm. So if you do, if you convert this 1150 mm into how much? 1152 meter, then we have to do the division with how much 100, division by 1000, then how much it will come? It will come 1.15 meter. Okay, so this is the meter. Now we are we are going to calculate for the number of the binder in waist slab. Okay, so to calculate the number of the binder in waist slab, what to do? We have to do the addition with the length of the waist slab by spacing plus 1. So keep these all value. Length of the waist slab we have 3504, and spacing also we have 150, and plus 1 is also we have. So keep this all, and then after calculation it will get the 24.36. This time you neglect this 3, because 3 is less than 5. Okay, so we cannot do the, this is the not the rule to do the random. Okay, this is the, okay, minimum you have to keep as it is. So this will be 24 only. So now we are going to, by taking this 24 24 number of the binders in the waist slab, we are going to calculate the number of the bar length. Okay, so to calculate the number of the bar length, what to do? You have to multiply 24 with the 1.15. Then after multiplying, how much it will come? Use calculator for this. How much it will come? 1.15 into how much? 24. How much it is coming? 27.6. So this is already converted in how much meter? So no need to convert this. Now coming to landing one. Okay, so to calculate the landing one, top binder bar. Okay, so this is the landing one. Top binder bar is this, and this is the bottom binder bar is this, and this is the top binder. This is okay. Now to calculate the bottom binder bar cutting length we have to calculate, and then number of the binder we have to calculate. Okay, similarly earlier, just now we have calculated. Similarly you have to calculate the total length, and then you have to calculate the total binder length. Everything we have, and the number of the binder we have, and last you have to calculate the total length. So all value you have, then substitute this length minus cover 2500 minus 50, it will be 2450 mm. This will be how much? This will become the 2.45 meter, and this will become the, after calculation, this will be the same number of the bars, and total length will be how much? 17.15 meter, and top binder bar will be how much? 5 number. Okay, and total length will be how much? 12.25 meter. Okay, so after doing this, we have to do for the landing too. Okay, to calculate the similarly, just now we have calculated in this way, also we have to calculate. We can calculate in the same way, we can calculate for the landing too also. Okay, so in the same way, how to calculate? Binder for extra bar, we have a formula. Landing cutting length is equals to length minus cover. Just now we have calculated. So substitute these all value for this also, landing 2 also, and we will get the landing cutting length will be 2.45 meter. And in the same way, if we calculate the number of the bar, then how much it will come? It will come, number of the bar is equal to how much? 6.64. And this time we have to do the round up. Okay, so because this is the greater than 4, so you can do the round up, then this will be the approximately 7 number of bar. The number of the bar will be how much? 7. Therefore similarly, total length now this time will be how much? We have to multiply this 7 number with the 2.47, because this is the cutting length we have to multiply. After multiplying, how much it will be? 17.15 meter. Now what we have to do is, we have to do the under waist slab. Okay, under waist slab is nothing but that is the gap between the riser and tread to the filling of the concrete material. Okay, so which is landed sloping, and is 45 degree. Okay, so that is the top mark to the 45 degree sloping ground. Sloping. Okay, sloping to the upward position. So that we are going to calculate it under waist slab. This is the number of the bar, and to calculate the number of the bar, what we have to do? We have to take the 450 by 150 plus 1. Okay, just now in early you have calculated this, no? This E by spacing, eccentricity by spacing, no? In the same way you can calculate. Okay, as you can see now, after see landing 2, and the number of the bar will be how much? Number of the bar will be number of the bar 7 by 47 by how much? 150 plus 1, and where p is the mm, plus d is equals to 250 plus this PR already we have calculated, okay, early 250. This is the width, okay, width of this beam, width of the landing, okay. So and plus 597, this also we have calculated, okay. So d value also we have calculated. Substitute this value here and then you will get the this here directly, okay. So as you can see, after calculating you can get the how much, you can get the 6.64, and this will be approximately, after rounding this will be 7. Therefore now total length will be 2.47 into 7. This will be, after multiply, you can do here, see, do the 2.47 into 7. If we do, then how much it is coming? 17.29. But this is the, see, actually this you have to the, this will be 70.15, okay. So now we are going to under west slab, so for this will be e by 150, just now I told you this will be 4 number, okay. If we do this, then how much it is coming? 450 divided by 150, if you do, then how much it is coming? 150 and plus 1, how much? How much? 4. 4 it is coming or not? Then therefore for under west slab, number of the bar is required how much? 4 only, okay. And therefore now total length, to calculate the total length we have to do the how, what you have to do, you have to multiply, 1.15 into 4, okay, with 4 number, then this will be 4.46, 4.6 meter. Then we got the total length. Now how much? Now we are going to calculate the binder for top value, okay. Binder for top value, what to do? Binder for top value, to calculate the binder for top value, we have to do the cutting length. We have to find out the cutting length first of all, okay. To calculate the cutting length at the top value, you have to do the what? To 2045 mm divided by 1000. If you do, then how much it is coming? How much? 2.045. So this is the 2.45 meter. So convert it into what? Meter. So similarly number of the bars is how much? Number of the bars is equals to d by 150 plus 1, okay. So d is how much? D already we have calculated, okay. So 567 by 150 plus 1, this will be how much? This will be, use the equal to sign here. So okay, okay. Now after doing this, how much it will come? It will come at approximately 4.9, 4.9, no, 4.9, 4.98 is approximately is equals to how much? Approximately is equals to 5, okay. No, sorry, uh, approximately is equals to 5, because this time you have to do the round up, and after decimal this is 9, so you can do the round up, and this will become the what? This will become the 5, okay. So total length, to calculate the total length, you have to do the multiplication with the cutting length into number of the bars. If you multiply cutting length into number of the bar, then how much it will come? 2.45. Cutting length is how much? 2.45, and how much? Number of the bar is how much? 5. So multiply this, how much it will come? It will come 12.25, okay. So this will be 12.25, okay. This, okay. In this way you can calculate, you can prepare the bar bending schedule for any part, okay. Any part, it might be slab, it might be column, it might be a staircase, it might be okay foundation, it might be footing. So this is the method, this is the process by which you can calculate for the what, you can calculate for, you can prepare, you can prepare bar bending schedule of building. Okay, so I think, hopefully I think you all like this video. If you like, then please don't forget to subscribe to my channel. And also lastly, um, also don't forget to subscribe. And lastly, don't forget to hit the bell icon in my YouTube channel, so that you can get the notifications, okay, when I will upload the new video in upcoming days. Okay, so this type of video I will bring for you to work engineers who work. Okay, so if you like, then please subscribe. And okay, and like also. Okay, so that you you will get the you will get the more knowledge about the civil engineers. Okay, so till then, tata, bye bye, see you in next video, guys. Okay.